In an earlier video, calculus video 345A, I have shown that we can use two foci, these two foci, to generate the points for this hyperbola. The link for this video is in the description section. In this video, we will use one focus and a vertical directrix. So this is the vertical directrix to generate the points for this hyperbola. So instead of using two foci, we will use one focus and one directrix to generate the points for the hyperbola. And then I will also show that the polar equation for this hyperbola is r equal to eg dividing by 1 minus e times cosine of theta. To generate the points for the hyperbola, we need to pick three things. So first, we need to pick a fixed point. We'll call it F. And we'll pick the fixed point at the pole here. And we'll call it the focus. And then next, we need to pick a fixed line directrix. So in this case, I picked the vertical line x equal to -8. And then next, we need to pick an eccentricity number greater than 1. So we want a hyperbola. The eccentricity number needs to be greater than 1. So in this case, I picked 4. And then next, we need to find all points such that this ratio, the ratio of distance from point to the focus, and then distance from point to directrix, this ratio must equal to E, which is the eccentricity. In this case, I chose 4. And so now let's look at these 4 points. So we have 1, 2, 3, 4. And now look at this point D right here. Point D is located at the coordinates of -16 over 3 and 16 times the square root of 3 over 3. And the corresponding polar point, so the polar coordinates for this point D is 32/3 and 2 pi over 3. And so now let's calculate the distance from D to F and then D to the directrix. So the distance from here to here is this, and it comes out to be 32/3. The distance from D to the directrix is 8/3. Because the distance from here to here is 8, and the distance from here to here is 16/3. So it's 8 minus 16/3, and we have 8/3. And then now let's calculate the ratio of the distance from D to F and D to the directrix. So 32/3 dividing by 8/3 is 4, which is the eccentricity number that we have chosen. And so that's what we want. We want all points such that this ratio is equal to 4. And now look at point E. And we can see that it's the same, it's very similar to point D. The distance from F to E, meaning the distance from the focus, which is the pole, to E, is 32/3. The distance from point E to the directrix is 8/3. And therefore, the ratio of the distance from E to F and E to the directrix will be 32/3 dividing by 8/3, which is 4, which is the eccentricity number that we have chosen. And now we'll look at this point C. Point C is located at the have coordinates of negative 10 and 2/3 and 0. So this point right here is negative 10 and 2/3 and 0. The distance from C to the focus from C to the focus will be 32/3, which is 10 and 2/3. The distance from here to here is 8. The distance from here to here is 32/3, and therefore the distance from C to the directrix will be 32/3 minus 8, which is 8/3. And therefore the ratio of the distance from C to the focus and C to the directrix will be 32/3 dividing by 8/3, which is 4, which is the eccentricity, and that's what we want. And now look at this point B, which is located at the, when point B has the coordinates of negative 6.4 and 0. Therefore, the distance from B to F will be 6.4. The distance from F to the directrix is 8. The distance from F to B is 6.4. Therefore, the distance from B to the directrix will be 8 minus 6.4, which is 1.6. The ratio of the distance from B to F and from B to the directrix is 6.4 divided by 1.6, which is 4. And that's what we want. So one more time, these 4 points, D, C, B, and E, all of them have all of them have ratio from point to pole dividing by distance from point to directrix is equal to 4, which is E. And then now we want all points. We want all of the points that have this ratio equal to 4. And here are the other points that also have the ratio equal to 4. And of course, all of these points together, they will form the hyperbola. And so, one more time to summarize this part, so to generate the points for this hyperbola right here, first we need to pick an eccentricity greater than 1. In this case, we pick 4. And then we also need to pick a focus point, a fixed focus point. And so, in this case, we chose the point 0, 0, which is at the pole. And then we also need to pick an eccentricity. We also need to pick a directrix. So in this case, we chose a vertical line right here. So the vertical line, it could be to the right of the pole, or it could be to the left of the pole. In this case, we chose a vertical directrix that is to the left of the pole. And now let's find the polar equation for this hyperbola. Let F be the point at the pole. Let D be the distance from the pole to this vertical directrix. Let P or theta be a point on the hyperbola. So this point right here is on the hyperbola. Since P is on the hyperbola, then the length of the segment P to F dividing by the length of the segment P to R, which is the distance from the point to the directrix, must equal to E, where E is a positive constant greater than 1. This point is R theta. Therefore, this angle from here to here must be theta. The distance from P to F is R. Now look at the right triangle P N F. This angle is theta, therefore this angle must be pi minus theta, or 180 degrees minus theta. The cosine of this angle, pi minus theta, will be the length of the segment NF dividing by the length of the segment PF. From trigonometry, we have cosine of pi minus theta is negative cosine of theta. And so we have negative cosine of theta is equal to length of segment NF divided by length of segment PF. So we end up with length of segment NF is equal to negative cosine of theta times the length of segment PF. But the distance from P to F is R, since this point is R theta. So we have negative cosine of theta times R, or negative cosine of theta. The length from P to R is the same as N to Q. But this segment NQ will be F to Q minus N to F. From F to Q, we call it D. So we have D minus negative R cosine of theta, or D plus R cosine of theta. Earlier we had PF dividing by PR is E. So this will be R dividing by D plus R cosine of theta. Multiply both sides by D plus R cosine of theta. Move this term to the left side. Factor out the common factor R, dividing both sides by 1 minus E cosine of theta. And this is the polar equation for this hyperbola. Once again, E is the length of P to F dividing by P to R, where E is greater than 1, and D is the distance from the pole to the directrix. I have just shown that the polar equation of this hyperbola is R equal to ED divided by 1 minus E cosine of theta. In this case, we have a vertical directrix to the left of the pole, and this is the corresponding polar equation. If we have a vertical directrix to the right of the pole, then the corresponding polar equation will be R equal to ED dividing by 1 plus E cosine of theta. If we have a horizontal directrix below the pole, then the corresponding polar equation will be R equal to ED dividing by 1 minus E sine of theta. And if we have a horizontal directrix that is above the pole, then the corresponding polar equation will be R equal to ED divided by 1 plus E sine of theta. And so here we have a hyperbola. The directrix is x equal to negative 10. So the distance from the pole to the directrix is 10. And so d will be 10. The eccentricity is 4. And therefore the equation is ED dividing by 1 minus E times cosine of theta. So this is what vertical directrix equal to 10. So here's negative 9, negative 8, and then eccentricity x equal to negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, and negative 1. And then now let's move the vertical directrix, let's move it to the right of the pole. And so now this vertical directrix is to the right of the pole. And therefore the equation will be 4ED dividing by 1 plus, instead of minus, E times cosine of theta. And here's x equal to 9, 8, 7, 6, 5, 4, 3, 2, 1. And now let's look at the case where the directrix is horizontal below the pole. So in this case, this is the line y equal to negative 10. So the distance from the pole to the directrix is 10. So d is 10, and eccentricity is still 4. And so if the directrix is below the pole, then it will be ED dividing by 1 minus E times sine of theta. And then now let's look at the case where the directrix is above the pole. So the distance from the pole to the directrix is 10. So d will be 10. So this is ED dividing by 1 plus E times sine of theta. So this is y equal to 10. So here's 9. And in summary of this video, so one more time, for the hyperbola, the eccentricity number must be greater than 1. And then if we have a vertical directrix to the left of the pole, then the corresponding equation will be R equal to ED dividing by 1 minus E times cosine of theta. If we have a vertical directrix to the right of the pole, then the corresponding polar equation for the hyperbola will be R equal to ED dividing by 1 plus E cosine of theta. If we have a horizontal directrix below the pole, then the corresponding polar equation will be R equal to ED dividing by 1 minus E sine of theta. And last case, if we have a horizontal directrix that is above the pole, then the corresponding polar equation for the hyperbola will be R equal to ED dividing by 1 plus E sine of theta. And that's the end of the video.